Okay, good morning everybody, and welcome to the Digital Innovation Network's first digital event. My name is Jenny Danson. I'm Assistant Director with the Digital Innovation Network and your chair for today. So today, DIN is hosting an introduction to digital twins and how they could work in social housing. We've got over 100 people signed up for today's webinar. So for any questions, please type them in and we'll aim to answer them as part of the presentation or at the end. So today, we've got two fantastic speakers to guide us through this next hour. We've got Kishore Ranjadran from Microsoft and Andy Barrow, CTO at ANS. So I'd like to be able to hand over to Kishore.
Thank you very much, Jenny. So please let me share my screen. Okay, so good morning, everyone. My name is Kishore Ranjadran, Public Sector CTO for London Councils and Housing Associations in the UK, and I'm here to provide an overview of a technology called digital twins and our solution in Azure and how that will help bring together various data sources, devices for more meaningful insights, simulations, and also enabling predictive modeling as well. So we'll take a look at it from a very high level today for the next 15 to 20 minutes. And of course, if anyone would like to go into it more deeper, we're more than happy to follow up on that. So let's first focus on the digital feedback loop. Now, some of you may have already seen this diagram before. We live in a data-driven world today where we leverage data from various sources, and using those insights and intelligence, we make informed decisions, whether that's helping our customers being more engaged by using various technologies and devices, or ensuring our employees stay more productive, or ensuring our operations are on top and ensure we have reduced costs. However, there is a problem, and the problem is the various parts of the business are not digitalized. So one part of the business, for example, operations, may be digitalized. However, when we have customer and employee engagement, that may not be digitalized. And the second issue that we have today is lots of data is siloed within different parts of the organization. And because we don't have access to that data, we cannot see the relationship between customers and products, customers and operations, employee and operations, and that whole digital feedback loop does not join together. And we'll come back to this in probably 4 or 5 slides time to go through how digital twins will help join everything together to provide meaningful insights. Now, if we take a look at the trend today in terms of going digital, we are experiencing about 1 million devices coming online per hour at present. That's quite a lot of devices, and they're not just mobile phones, laptops and tablets, traditional devices that we're used to, but also other devices such as cars. More and more cars are now connected via onboard SIM cards and sensors. We're also seeing smart office scenarios grow, as well as smart buildings, and we'll come on to a demo of that later on. And of course, we're seeing millions and billions of IoT sensors transmitting data, very meaningful data that can allow us to focus on various different scenarios. And a few of those scenarios are actually highlighted on this slide. So if we take a city, for example, some of the things we can do from those enhanced devices being connected online is we can ensure effective traffic management and also modernizing parking. Rather than having meters in the streets, we can actually use cognitive services and image feeds to manage that better. Housing, there is a lot of discussions and work going on when it comes to smart buildings. So how can we ensure we have advanced monitoring and predictive monitoring, so we can resolve issues before they happen to minimize costs incurred to businesses that are managing properties. How can we ensure an enhanced living condition for citizens in those properties, and also how can we ensure safety as well for citizens living in those properties. And again, those items I will come back to in more detail when I go through a quick demo towards the end of this presentation. And of course, we have a few other things on the example slide. Utilities, how can we manage utilities more better through a connected grid? Citizen engagement, ensuring we can connect with the residents in our properties a lot more effectively using these various devices that are coming online, and safety that I mentioned earlier. So there's a lot of scenarios that we can enable as a result of lots of these devices coming online and the connectivity and the data that these will provide. Now, if we take a look at a very simple scenario, if we have an IoT solution, we have things. Things represent devices that send us data. Could be a heat sensor, for example, a temperature sensor. Could be a moisture sensor fitted on a water pipe to measure if there is leakage happening. Could be some sensors in the lifts that ensure predictive maintenance can occur when parts are about to go end of life. Could be motion sensors to detect if there are people in specific parts of the building in a fire scenario. So things are effectively devices that can, IoT connected devices that can send us data. Insights, what can we do with that data that we receive from these devices? And actions, the various scenarios that we can achieve as a result of these insights that we've been able to get. So it's a very 1,000-foot view of an IoT solution, but in reality, it's not as simple as that. We have a lot of things we need to consider. We need to consider scale. So how can we scale IoT deployment in a cost-effective manner? Because if we do not think about, and if we do not architect correctly, costs can spiral a lot greater than the benefits we will get in return. We will also need to ensure security of our devices and gateways and edge devices. We need to think about disaster recovery. So what happens if we lose connectivity? What happens if the devices are maliciously damaged? How are we going to still keep retrieving data? We need to think about monitoring costs. There's a lot of operational considerations that need to be taken care of. And this is one of the reasons why IoT needs simplifying. And that's where digital twins comes into play in helping us simplify the delivery of IoT. So digital twins, let's take a look at it in a very high level. So digital twins effectively combines the physical world and the digital world together. So we can take any object that we have today. An object could be a high-rise building. An object could be a vehicle. An object could be a desk in an office space. It could be any physical object that we have today. We effectively merge that with the digital world. And what does the digital world mean? Digital world means data that can be retrieved from those sensors and devices that are connected to the internet. So the many million devices that we saw earlier in the slide. So to give you an example, what does this look like? If we take a building, for example, let's take a specific floor in a building. We'll have a floor plan. That floor, we may have various sensors. We may have a temperature sensor, a fire sensor. We may have a moisture sensor. We may have a movement sensor. We may have a light sensor. We may have an energy monitoring sensor, a water usage sensor, various sensors. Those sensors will be in certain parts of that floor. So when we combine that floor into a digital world, we will effectively place those data points in those sections of the floors. So we'll be able to accurately monitor the utilization of a space, depending on the sensors that we have, accurately monitor and predict consumption, for example, how much energy will be used in the physical area of a high-rise building, how many hours a light is typically needs to be turned on. So we'll be able to do various predictions as a result of this fusing. And using artificial modeling, we can also model for various items longer term. And I'll come into these in a little bit more detail later on, but that's just an example of how digital twins helps. It brings together all those various individual and disparate data sources into a single point. It merges those data sources with the digital version of the physical assets, whatever that may be, and that allows us to have real-time analytics, real-time predictions, and also simulations as well of what would happen if a certain scenario occurred. Now, in terms of model interactions, there's a lot of technical items that we have to consider. So, of course, with any device that we have, we need to have a gateway that devices connect to, and then we need to also have an edge in the cloud to ensure that we bring that data, we process that data, and that data can be sent to various parts for processing and also for various modeling and algorithms. Now, this is a very, very high level of the solutions and the technology in Azure that can be utilized to get going from having a device that's connected to the internet to carrying out various data manipulations to having a result of what that looks like to an end customer. And I'm not going to talk about this in more detail because this will require a very deep technical conversation to be had, but this is just a very high level of what that interaction looks like, from physical to the cloud, to analytics, to the business results that we can expect in the end. And some examples of digital twins here. So in fact, I'll skip the slide. I'm going to go to smart spaces, which goes into more detail of how digital twins can actually work in a bit more detail. So if we focus on smart spaces is one of the key scenarios that we had in mind when creating the digital twins solution within Azure. So in a smart space, we have building operations. This includes HVAC, heating, ventilation, air conditioning systems, BMS, building management systems, and various other systems that enables that building to be managed operationally more efficient and securely. We also have various security infrastructure that could just be a very simple CCTV camera to some advanced entry systems that is connected online. We also have various other data sources coming through, such as interactive walls, digital assistants, to ensure we provide an enhanced service to its people, residents, tenants, office staff, workers in those buildings. We have various services to help make it better for people working or living in that area. For example, identifying where an individual is in that building using People Finder, and those technologies exist today, as well as various other services such as concierge. So rather than having to phone, we can identify where those services are, for example, a vehicle arriving to the building, to ensure we give a better satisfaction to people living in those properties, and also engagement as well, to have a more deep level engagement for people living in those areas. And this, let me go into here. I'll skip these quickly. And this comes into our office intelligence and spatial intelligence of how we can ensure that pyramid connects together with people and with data that is coming from sensors to provide a very meaningful modeling and simulation to achieve the end result. So this is a typical user, and this is various interactions that user has on a day-to-day life. And this is set in an office scenarios. They will have meetings with groups of people. This individual will send emails, create slides, and so on. But this is only for that individual. There is no merger with various other data, for example, building data. Now, where spatial intelligence comes in is that individual, we will understand the interaction they have with their devices. So typical device a user has interaction with is mobile phones, their devices such as laptops, tablets, and also smart wearable technology as well. So in this scenario, we have a wearable device such as a smart band. And this is individual user interaction. And if we then combine it to interaction with spaces, we then know where is that user present. So are they working from home? Are they working for an office? If so, which part of the office are they working from? Who are they meeting? How long those meetings are taking place? How productive is that person being? And we can then further connect those spaces with various other devices that interacts with that space. So if we know that this user is going into meeting room A, and that meeting room has a projector, that meeting room has a temperature sensor, that meeting room has a wipe system such as a phone system, we also can ensure we have a better understanding of the user's interaction with the space that they're using. And we can go one step further as well. We can then start to look at sensors as well in those spaces. So take a look at, is that condition in that room an ambient condition from a temperature perspective? Is too much sunlight coming in that is impacting visuals from a meeting? What is the noise? Do we have effective insulation in that meeting? So various other sensor data comes in. So this is one half. If we then merge that with what we saw in the other slides, the day-to-day interactions of that user from a digital world, and we combine those two together, that's when we have a very powerful spatial intelligence graph built. And this will now enable us to identify what the user has been doing, what interactions has that user had with the workspaces that they had whilst they were carrying out a specific task, how comfortable was that user at that given time, and we can carry out various different analysis and also have various different modeling. So what would happen if we remodeled the office space? How will that affect an individual user's experience when they carry out various tasks? And this is what we call spatial intelligence, bringing together all these sensor data from devices as well as the day-to-day behaviors of users together and merging that into a single place, which digital twins allows us to do. Now, this is just an example of digital twins in the smart place. I'm not going to go through this in more detail because this goes into the technology of digital twins, but I just wanted to have this slide to give you a bit of an understanding of the various technology elements involved when we start looking at the Microsoft Azure cloud and how we would bring together all of that data and sources, which we saw in the earlier graph. And also some examples as well from an interaction perspective for users. How does that help? For businesses, how does that help? Is to ensure that we enable productivity and the best environment for a user to work from, but also at the same time to ensure that those physical assets are managed more effectively to reduce cost, to enable better user experiences. Now, what I want to do is show a demo of what this looks like. Because digital twins is brought to life when we start looking at demos rather than talking about it in graphs. So I wanted to show you a real life demo. This is a demo which Microsoft has built along with Johnson's Controls. And this is a building management system demo. So we have quite a lot of buildings here. We have in the US that we're using as part of this dashboard. And you'll see there's some key metrics. So you'll see energy consumptions. And the reason it spikes and it decreases is because this is during working hours, this is during non-working hours, so Saturday and Sunday, for example. We see overall metrics. We see office utilization is quite low compared to energy efficiency, which is quite high, so very efficient. How often those office environments are open for use, how we're using storage effectively, so various KPIs there. And we also see some incidents that has occurred in our office spaces. And these incidents are both real time and also predictive as well. So remember I mentioned earlier, when we start bringing together all that data, we can build modeling to ensure we have effective predictive technology in place to detect issues before they happen. So some of these are real time and some of these are predictive. So it's actually giving us an alert before an issue occurs. So it's telling me there's 2 issues right now in Seattle and New Orleans. Let me click on the New Orleans building. And it's giving me, first of all, a model of the building. So I can switch between floors. So I can go to the ground floor here. I can go to floor 2, floor 3, 4, and so on. At the moment, the sensors are only installed in floor 3, which is why you see all these dots. And in the other floors, we do not see those sensor data coming in. Now, I can get the temperature and the humidity right now. So it's telling me 70 Fahrenheit with 13% humidity, 61 degrees Fahrenheit here. If I want to understand, is my office environment in a good state, for example, from a temperature, a very comfortable state for staff to work in, I can actually have a model. So right now it's telling me that based on the current information and previous historic data, this part of the office is too hot most of the time. This part of the office has medium heat going through, and the other part of the offices have very comfortable working environments. Sorry, this graph here. So anything in red has too much, it's too hot in that area, and anything that's not red means the working environment is comfortable. Now, using this data, we can automatically enable those temperatures to be reduced in these part of the areas, and digital twins along with automation will allow us to do that. We can also take a look at what will happen if there is too much sunlight coming into the building. So this is telling me that sunlight, if it comes from any part of the building, this is where the most users will be affected with sunlight hitting their monitors, so they don't get a very good experience because there will be reflections on the screen. However, users in this part of the area will not get a lot of sunlight coming in, so we can do some modeling there. We can also see the HVAC installation, heating, ventilation and air conditioning systems of how they are installed in the buildings and various sensors along it. Now, there are some metrics here at the bottom, but the key thing is we have a critical issue with heating, ventilation and air conditioning unit here. So if I click on this, it gives me a digital twin of the HVAC system. So this is a digital twin, which is a physical system mapped digitally, and various sensors that is present in the HVAC system. Now, I don't see any errors here. Everything is working fine. The reason we have a critical issue flagged up is based on my predictive data modeling, so based on historical data that we've gathered and modeling that we've carried out. It is telling me that today we will have a critical alert coming through because over the next couple of days, there is a high chance of a part failing. So you'll see this graph here increasing and there's critical alert bar set here. So in a few days time, the critical alert will actually cause a part to fail. So we've got an alert today to request us to analyze the HVAC unit, to request us to service this unit to ensure that we identify any issues before they occur in a couple of days time. So I can click schedule maintenance and I can connect this directly with Dynamics 365. So Dynamics is something which a lot of housing associations use today. And also I can notify the building manager to ensure that this is resolved, and I can set a deadline of when this will be resolved. And when I hit submit, the appropriate tasks are sent to the people that needs to be notified. So the building manager is notified, the engineering teams or the maintenance teams are also notified at the same time. A work order is created and they will then be able to go and investigate those HVAC unit in more detail. So this is just a very simple example of digital twin. So this is a building that we've twinned. These are various sensors in the building that we've added based on the spatial locations where they are. And with the physical building and with the IoT sensors that we have, we merged them together, and utilizing that overall spatial awareness, we're able to create modeling such as this. And this is effectively what digital twins is from a very high level. So with that, I will wrap up and I will hand over to my colleagues, I believe Andrew from ANS.
Thanks, Kishore. Wonderful. Thank you. Adrian is just brilliant. Well, what a wonderful overview that was. So the first thing I'd like to do is I'd like to thank Jenny from Digital Innovators Network for the opportunity for us to present today. And I'd like to thank the guys at Microsoft for teeing that up really well. Thank you so much. Hi, everyone. I'm Andy. I'm the Chief Technology Officer for ANS. It's something that we've spent a fair bit of time on, building digital twin solutions for customers. It really is an evolution of IoT. So for those out there who are familiar with IoT, like Kishore said, they can be quite difficult to build in the fact that when you've got lots of sensors, lots and lots of data, you then need to build a lot of database schedules and software on the middleware to integrate all that data into one central place. You can actually build a digital twin of something. Some of the challenges have been actually that the sensors that you buy, you might need to make your own sensors. So that's one. A lot of early adopters would do a prototype sensor and then they would have that manufactured somewhere, they would trial that, and then they would effectively have that made on a mass scale. More and more sensors are now available off the shelf, which is great at a much cheaper price point. I was going to use an example there of my wife bought a new set of trainers that turned up this morning for £60 that have got a sensor, the Under Armour ones that have got a sensor in them. You wanted to do that 3 or 4 years ago, you were probably talking a couple of grand for a pair of trainers with those sensors, and it connects to Strava and it does all of that. So you can really see that the price of the actual edge sensor technology has come down to such a point now, it makes it more feasible to place sensors in many more places than what we typically would have before. The challenges are that you buy products that have already got sensors in them, you buy third-party products, you've got some products that have got their own platforms, and integrating all that data into one coherent way is actually one of the areas that's really quite difficult. So that's really where digital twin comes in, because digital twin is an evolution to make IoT much easier to consume, and the Azure Digital Twin service is one service in the cloud that effectively allows you to build those solutions at a much cheaper price point and get better situational awareness, remove a lot of the duplication of data, and effectively allow you to improve the operational decision making. And the other thing that they're designed to do is to integrate into systems that you've already got. If you run in your organization from a CRM, or you've got ERP or field service management software, you basically are presented with a data integration point that then you can enrich what you already have with more and more and more data. So we're seeing now digital twins, obtain rapid growth as the software becomes much more prevalent and the price of edge sensors actually comes down. There's a quick question before from Helena on the chat that talked about, wonder how easy it is to retrofit into existing buildings. Well, it's actually quite easy, and that is actually the majority of the market, for a number of reasons, really. A lot of buildings are built still today without them being censored up, if you will. They're one of the costs that can sometimes come out. So there will be some things in the building that will have data points in them already, like we talked about the HVAC system, the aircon system, things like that are already tend to be quite smart. But there's lots of things and lots of opportunity to retrofit, and some of the things that Adrian, one of my colleagues, is going to talk about shortly is how we've done just that. That's one of the main things. Another question from Leslie was around COVID. So yes, there's definitely an increase in temperature sensing, and social distancing effectively is becoming a market in a very short space of time, and all the sensor manufacturers now are effectively almost touting that they've got temperature sensors that can effectively analyze humans in real time as they come into a building, so it can give you some form of alert. So absolutely, those are a couple of use cases there that can be done, and we can continue the chat on that later. But yes, retrofitting buildings is actually one of the biggest markets actually. There's three types of digital twin in conceptual terms. Don't worry too much about this, but you've got the ones that deal with things, which are effectively discrete digital twins. Then composite digital twins was like what Kishore was going on about before, where you're enriching it with much wider data. And then you've got an organizational digital twin, something called a DTO, which effectively allows you to map out business process. It's a full model of the organization where you take it all the way. So you can kind of see those three markets starting to emerge. And it's a fantastic place to be working in at the minute, and there's some incredibly exciting projects. And one of the projects that we've done that I'm going to just quickly hand you over to Adrian, one of our solution architects who knows this customer and project really well. We were lucky enough to deploy one of the first digital twin live deployments in the UK. So I'm going to hand you over to Adrian, who's going to talk to you a little bit more. I know Kishore's done a wonderful demo there, and thank you very much for that. We'll just do a quick one on this case study for Bruntwood. Go for it, Adrian.
Andy. Hi everyone. So yeah, as Andy said, I just wanted to cover what we've done with Bruntwood. So start with who they are, what they wanted to do, how they wanted to do it, how we got them there, and what the outcome was. So Bruntwood, for those that don't know them, are a building and facilities management business. They let, manage and own workspaces and buildings. There are about 800 people. Some of their buildings are innovation science facilities, and because of that innovation side of things, they wanted to be the first UK deployment of digital twins, which they were, and they've got 120 buildings. So what they wanted to achieve, their outcomes were they've got a lot of disparate data, which everyone has. So they had an example of different BMS systems across different locations. They had different door entry systems. The data was all in different formats. It was inaccurate in places. It was hard to get, and they had some existing processes which were more the field service type of processes, which were an engineer would like to print out a piece of paper, go and do that task, write it down, and then hand it to someone to enter in the system at night. Hard to kind of get around those non-IT processes. And their aspirations were to automate a number of those processes, so to reduce that kind of overhead, reduce labour costs, and that was more around the predictive stuff, which we've already discussed, but more around rather than just going out every 6 months or every year to repair or replace a system or a device, just do that when it's actually needed. And also some compliance as well. They want to be compliant against ISOs and building regulations. So when we initially sat down with Bruntwood, we went through a number of key systems we could bring into this. So we broke it out into smart buildings, occupancy, productivity and security. And then we delved into each one of those areas and looked at which one would bring in the most value, which was, well, I hate this phrase, but low-hanging fruit. Once we'd identified that, we looked at what sensors were out there on the market that were relatively easy and quick to bring in. With Bruntwood, we use Yanzi sensors, which was easy to get the data out of. We could integrate them relatively quickly, and they were cheap enough to get out there and get out there on scale. We also wanted to bring in other data as well, so it wasn't just about sensor data. We brought in security data for a car parking system, ran that through the Azure AI cognitive systems services, to pull in car park utilization. There was more as well, so we had cleaning data, but those were just two examples. So once we got that data in, we used digital twin because it's just a scalable, easy solution to use. It simplified it. Before digital twin, we'd have to build a database out. We'd have to create relationships between sensors and buildings. We'd have to do a lot of work up front to get to a point where we could use the system properly. Whereas digital twin just solved a lot of those problems for us. In this example, it's a tool that Microsoft have launched that integrates digital twin, where we can visualize the relationships really easily. So in this scenario, we've got the rooms for a building on the left-hand side, and it flows through to what those physical things are, and then the digital representation of that, and what the sensor is and how it's working, and what data we can pull from it.
So Adrian, just on that there, then each one of those blocks is a digital twin.
Yes. So each one is a digital twin. So in the left, for example, is a physical room, and in the room we've got chairs in this room. So now we've got chairs, plus we've got motion sensors. Each chair has got a physical sensor connected to it, and then these are the data points that the sensor's coming from.
So everything's, you're building the relationships between all the way through in a hierarchical way that allows us to collect the data in a stream, and then you can effectively run a query against that data in real time.
Yeah, so exactly that. So what we don't have to do now is query a sensor. So we don't have to say, I know that a sensor in a certain room or a certain location is sensor 8829, whatever it is. Yeah. What I can do now is, using digital twin, I can query, show me all boardrooms, or all one-bedroom apartments, or all kitchens, or all bathrooms, and then show me what the humidity is in each bathroom, or give me an alert if humidity in a bathroom goes over a certain level. There's things like we can do directly in the digital twin platform. And previously we had to build all that manually, and it just took forever, right? It wasn't scalable. It was manual. It was a pain previously. So before digital twin, it was a pain. And digital twin gives us that real-time view of everything across the and we effectively build our applications on these graphs. So the application that Kishore showed before is effectively built on top of the graph that you're looking at now. Exactly. Exactly. So once we've built the digital twin out, and we've got our digital twin platform built, or our database built, building then some nice visualizations that we can put in the hands of the engineers and people doing things, or the businesses or facilities people. You can quickly and easily see the state of their entire business, what things are running, where they've got issues. We built a number of graphs out for Bruntwood, so they could quickly and easily see the state of play. So a couple of these are hot desking locations, but we built more out for them as well. So we built out area utilization, so what areas are being used and not used. And this was more around, obviously it's quite a lot of expense per square foot, and if a large chunk of that was on a reception area that was never used and people just quickly walked through there, then should they refactor that and bring more desk space into that area? They also sell space, don't they? So they sell per square foot to commercial use. So for them, it's a huge ROI generator. Yeah, exactly. Desk utilisation, so they were looking at more of the WeWork model in some areas where they sell per desk, and just wanted to know what utilisation was on that, and could they get more desks in there? What was again the ROI on that? What if they put more desks in, would they get occupancy in there? Occupancy across buildings and across the state. So occupancy, we built this out, everything from meeting rooms to desk space to communal areas, right through to where showers being used. Did they need more showers, need more toilets, and that kind of area? We brought light in as well, so light, noise and air quality, so more of the is it a nice environment to work in? Is the CO2 too high in certain rooms? Can we bring the noise down in certain levels? Do we need quiet areas and breakout areas?
We see the CO2 one a lot, don't we, Adrian? Because we had that in our office, didn't we, when we first deployed a smart spatial intelligence solution in ANS HQ. You were talking 5 million. You watched the CO2 gradually, which is why people were getting tired in the afternoon. So it's sort of, that can automatically kick off a ventilator or even just a simple email workflow to open windows or whatever. But it's surprising just in a general office space how much CO2 develops over the course of a day. It drops back to pretty much zero overnight and then takes to about 10, 11 o'clock in the morning when you've got a couple of hundred people in there and you can see it on the monitors.
Yeah, it showed it straight away, and same with Bruntwood as well. And straight away we started this with let's get facilities out there, as you say, opening windows or turning air conditioning units on or pumping more better quality air in there. Then it will eventually, we're going to integrate this with BMS systems, and we're going to get data in there. I'll pull HVAC systems in there as well to automate a number of those processes, as well as CRM as well for kind of the field service stuff. Just bringing that there is an issue, send that process through. So because of this now, so Bruntwood have improved their spaces. They're getting better interactions with users and devices. We've built for them now a people-centric IoT platform. So this is integrating with their new app. They're the first UK business to build digital twins out. They're now using the data that's generated from this to the next buildings they're building will be completely digital enabled, and they're building the workspaces around the data they've collected from the sensors in existing buildings. So the buildings that we've implemented these in had no, they weren't smart at all. They were relatively old buildings, 60s buildings in most cases, and we retrofitted sensors across them and created those data points. On the back of that, the CIO loved the solution, talks about how data is key to their business, and just how this is going to drive their business going forward. And they are building new buildings at the moment that will be completely digitized, and we're getting involved in the architectural side of that from what's going to be built from ground up.
Wonderful. Yeah, great.
The next phase of this is creating that CRM interaction. So bringing the data in from the digital twin platform and using Power Automate or something on the automation tasks to drive that there is something wrong or something has happened or something is going to go wrong, right through to CRM to get field service people out there and to action those tasks. And it's removing a lot of that paper and people process away from, you don't need to go and print something out, get it signed off and go and do it, and then bring that task back in. You can do it all in a nice app that's built on Power Apps, that's already integrated with CRM, that automatically bills customers if needed when a process has been done, or creates approval processes in the background. We've got a real-time view of that process as well, so in real time we can see something has gone wrong or is about to go wrong. We can see where the engineer is and when they're going out, and we can create that customer-centric approach to this as well, where we're contacting the customer before something's gone wrong, letting them know that someone's on the way out. This is the reference number. Someone will be there when they're going to be there, and create that view as well for the customer. Wonderful.
Since that's a long-term project, then, as we keep building that out.
Yeah, we're constantly working with Bruntwood now. So yeah. I've literally, as we're in this meeting, got another message from Paul just saying that we need to integrate with a new sensor now. So bringing on new cleaning sensors and different buildings have got different types of, as I said before, security systems. We're integrating with those, different BMSs per building, trying to get the data out of those and talk back to them as well and create that two-way model of data flow.
Great stuff. Much simpler on digital twin. Well, thank you very much for that, Adrian. So that sort of brings us to the end of that, really. I know there's been some questions going down the side. I think Nathan's one of our engineers as well who's been on there that's massively helped. But I appreciate everyone for the time. Thank you very much, Adrian. Thank you very much, Kishore and Jenny. And I'll hand back to Jenny.
That's great. Thank you. We have got lots of questions on there. So I think if we start at the top and then open it up with the team. So Leslie's asked about the impact of COVID and if we'll continue to accelerate smart use of technology. Who'd like to pick that up?
I can take that. Yeah, definitely. So it's interesting, really. I think people may start to, this is an opinion, not necessarily more, but I think certainly canvassing the organisations that we work with are interested in how they can use what's happened in the last 8 weeks, maybe longer, to an opportunity to maybe redefine the workplace or redefine the spaces that they use. So social distance isn't necessarily seen as a negative. It's something now that we can start to reorganise how we actually work. And a lot of organisations I'm working with are looking at how do they do that. So once we start to return to some form of normality, what can we do? And that involves sometimes maybe using the space a little bit differently. So the first thing really that we've had some inquiries on is around temperature. Absolutely 100%. There's some very cost-effective sensors out there that effectively will allow you to monitor temperature in real time. And that will just give you an idea if at least people that are walking into the building or the workplace are at the correct temperature. So those kind of sensors have actually been around for quite some time. It's just that now it's much cheaper and cost-effective to deploy those now with that technology. So that is absolutely something, and you'll see there's a lot of noise in the marketplace around organisations wanting to now start to add temperature, and it's not just temperature of a room, it's actually analysing, spotting that it's using some effectively cognitive services, some AI in a camera that picks out and goes, that is a human, what is the temperature? So there's a lot of those solutions becoming much more prevalent in the marketplace, and I think just redefining how space is used, making sure that people don't congregate in one area, so you can start to do some space management, you can start to do some proactive management of where maybe you sit people. We've already started to look at that at ANS HQ, which has got a big almost call center, contact center for the network operations center in there. So how do we redefine that? And we have a smart office technology in there. We actually have the solution similar to what Brunt would have, and because of that, it's allowing us to just make some better decisions. So in answer to the question, yes, my belief is that people will start to look more at these kind of solutions to sort of help benefit, the return to work and the return to office space in the most cost-effective way possible. If Kishore's got anything to add, maybe on mute.
Yes.
There you go.
No, Andy, I think everything you mentioned, completely agree. I think one thing I would also add is the smart technology and IoT will actually be of greater benefit in public spaces. So I know we've talked quite a lot about buildings, parking, and office and residential areas. But if we start to look at public spaces, for example, train stations, airports, bus stations, communal areas, busy parts of the city, I think in those areas, that's where the acceleration of IoT will greatly help, especially post-COVID. I think examples you used, Andrew, things like ensuring we can detect temperature people, having the relationship between the interactions that people make to accurately predict which area will be the most busiest, so we can have relevant procedures enforced in that area. Yes, I think we'll probably see an acceleration, I'd say, after COVID.
That's great, thank you. I think there's been quite a few questions, just moving it back to a social housing setting. So, Andy, do you want to give some of the examples that you've looked at from a residential sector?
Yeah, of course I can. So I think the residential sector, it's been, I suppose, when you're kind of looking at many homes as one solution, it has been traditionally potentially quite, with two challenges I've seen. So the first one being the cost of deployment on a wide scale in residential, when you've got, lots and lots of rooms to do across a whole piece. And the other one is that some of the solutions on the marketplace are quite tied and quite locked. So there's two types of solution you can buy. The first type of solution is a solution from somebody who has something pre-built with a sensor, with a platform, with the analytics, with everything almost ready to go. The challenges with those solutions, they're quite turnkey and can be quite quick to set up because the complexity has been removed. So they are effectively SaaS based. But actually getting at the data underneath and integrating that data with other data as the solution starts to grow arms and legs is sometimes quite a challenge, because those manufacturers like to keep you into their licensing model, and they don't necessarily like to provide an open API to give you a more richer experience as the solution grows. And what that sort of meant is that some organizations, I know we've gone down that route, have ended up with multiple different solutions and an inability to actually create a central repository. They're all siloed, which means that certain people in the organization have got access to certain parts of data depending on what solution was deployed, and there isn't one sort of central data lake repository that we can build out apps in a very easy way. So that's kind of some of the challenge. So the other type of solution is where it's integrated, where you use something like a digital twin solution in the cloud, and then you integrate to your needs, and you basically buy sensors from manufacturers that actually have open standards and open networks. Some of the sensors that we're using now, they're made in Scandinavia. They cost €1, and they've got a 15-year battery life, and they do all sorts of real simple things like, is the door open, is the door shut? So what you can basically tell, really simple, but has that person left the property recently? If you can model out over time that person generally leaves once a day, once every other day, but then doesn't for 3 or 4, you can raise an alert because that's out of the normal. The point being there is that it's a very cheap way of doing that. We basically just insert it into the door frame, and it costs €1. They also do temperature. They have one that does humidity. So you're talking about, kitting out a residential facility much more cost effective. And what they also do is they just provide an API to the cloud provider. So the data just goes in, and it's a charge for how much data is ingested. It's actually quite easy to work out, quite simple. And then what you do with the data there, whether you integrate that into your CRM, whether you integrate that or you just build a simple low-code Power application, or you actually build a full-blown solution, is down to you. There's no ongoing licensing costs. So we start to see that for residential properties that are going out at scale, these sort of solutions are starting to be much more prevalent now, starting with some of the simpler things that are a bit easier to solve. Maintenance is one. I know there's a couple of organisations that have turned many household boilers down 5 degrees because what the boiler was saying it was, and what was actually being kicked out, there was a 5 to 10 degree difference. You add that up over a significant amount of time, it's a lot of money. So it's basically making sure that the ROI is there in a way that you can build the solution in a cost-effective nature, that the return is there to generate. Over and above, I suppose, just providing a better experience, which we all want to do, but sometimes, it is challenging from a business case perspective. So that's sort of a little bit of the ones that I've been working on, if that's all right, if that gives you a bit of an idea. But more and more, there's more and more, cheaper price point sensors coming out with longer battery lives, because battery is another one that you have to look at, because if the device needs plugged in, it can be unplugged. But if the battery needs changing every 6 months, it's not cost effective from a maintenance perspective. So, sensor technology is really moving along the lines, like some of the ones we're deploying, like I say, have got 10, 15-year battery lives. Those Yanzi ones that we talked about before, I think they're 3 or 4 years. So again, it's good from a cost effective maintenance perspective. But going out changing batteries in 10,000 devices is not cost effective every year or every 6 months.
Thanks, Andy. Kishore, do you want to build upon that around water, perhaps?
Yeah, so I would like to talk about 2 specific things. And this is actually a project that we are currently partnering with an existing housing association right now. And once completed, we'll actually be the first in the UK to have implemented. So there's 2 things I want to focus on. Number 1 is water damage, and number 2 is fire safety, which I think Mark has also asked in a question 2-3 minutes ago. So water damage, the specific housing association are currently spending in excess of 20 million a year to pay for water damages. That's not just for repairs, but it's also to do with insurance claims as well that occur as a result of water damages. A majority of them are in high-rise residential buildings. So one of the things we're currently working on is ensuring how we can detect moisture and how we can detect leaks of water from the pipe using devices. We're actually using Bosch devices in those scenarios, in addition to measuring the sound of the water in decibels that is flowing through the mains and the water pipe sacks going into the properties. And with all these data over a period of time, we can accurately predict when an incident will occur. So, for example, when the leak will start to become a burst water pipe and start to cause damages. So they can have those predictive, preventative activities carried out in advance, so do all the repairs beforehand, before those damages can occur. And the benefit of that is those 20 million per year recurring revenue hit will start to decrease as they reduce the amount of damages that burst water pipe costs. And I think from a fire perspective, with the same housing association, we're fitting temperature sensors alongside their carbon monoxide and fire detection units. And what this allows us to do is we actually looked at the Grenfell example. So high-rise building, if there's a fire, number one, we need to identify who's still stuck in their apartments, in their properties. And number two, ensuring that firefighters can reach specific parts of the building safely and quickly, instead of having to assess each and every single floor if it's safe to proceed or not safe to proceed. So using digital twins, using temperature sensors fitted to the existing fire detection units, we're very accurately able to showcase which parts of the buildings are safe, which parts of the buildings are not safe for a firefighter to enter in real time. And we're also currently working on data sharing agreements between this housing association and the fire brigade, which means the fire brigade, the commander on site, will also have access to that data on their devices that they carry in their hands. So they will be able to reach various parts of the buildings quickly, and at the same time they'll know which part of the buildings they need to deploy more firefighters to tackle the fire to make it safe. But more importantly, in terms of identifying where people are stuck inside, now this specific housing association already had motion detectors in front of each property doors, and those motion detectors right now turns on and off lights, automatically turn off lights and automatically turn on lights to save on energy. So we're taking that data and we're looking at who's actually entered a property compared to who's exited a property. Now, this is not 100% accurate data. There will be some anomalies and it's not going to be accurate, but we predicted it's about 60% accuracy. And we will also be able to give the firefighter commander on site and the building maintenance manager on site around a 60 to 70% accurate view of who is currently not exited their property in that apartment, for example, in a high-rise building. And again, the firefighters will have that data and they can focus their rescue efforts rather than having to guess who's stuck in the building, who's not stuck in the building. So they're two real-world examples that we're currently working on today of reducing costs and improving rescue in a fire scenario for a high-rise building.
It's really interesting, Kishore, thank you. We've got a lot more questions coming in. So one I'd like you, Kishore, perhaps to pick up first is just around the, although a lot of that you've probably made a very good business case for it from fire, but what is the business case for digital twins, and give some examples of that and how BIM may support the use of digital twins.
Yeah, absolutely. I will probably say three reasons. Number one, a single accurate view of all your assets in one place. Now, we work with many housing associations across the UK, and I know we still have few housing associations who use spreadsheets to manage their assets, so all the portfolios that they have under the umbrella, and also we do know some housing associations also struggle to get building floor plans readily available and quickly, and sometimes we have to wait 2-3 weeks to have those available. Now, digital twins, first of all, gives us a single view of your assets in a very detailed view. So there's no need to use spreadsheets. We can see all the property portfolio that we have in a map. We can click on a specific property portfolio. We have the building performance data, so the building management systems, which for most properties are local. They're not networked, which means you can't access that from a command center, for example. You will be able to view all the BMS systems from a single point of view, let's say a command center as an example, in addition to the floor plans of the building, the various improvements we're making, all the tasks that we're being assigned for engineers to go and carry out, as well as any other reasons. A single point of view, asset management, that's the first key benefit we will get, which we have seen not many housing associations that we work with have that comprehensive end-to-end solution for all their property portfolios. Now, the second is the ability to carry out simulations. Now, one of the key things, if let's say we have a reception when we go into a high-rise building or a low-rise building, and we want to see if we demolish that reception area and maybe build let's say a shop, for example, how will that affect the flow of people that are entering the building? How will that affect the space required for evacuation in a fire scenario? We can accurately simulate what would happen if we made changes to the existing architecture of that building before we actually carry out the changes. So we can have very predictive simulated models that helps us to understand the impact, whether that's positive or negative, of making a certain change to the physical structure or the physical element of a specific building. And the third is predictive maintenance, which I've already talked about with the water example. I think the more information that we have and the more data that we gather, the better those predictions will become. And anything that we can fix before it fails is always a good thing, because it's ensuring that we save costs and we also keep the residents happy, and then we have a high satisfaction to them. So I think from a business case perspective, I'll probably mention those as my top three if I was building a business case to have these digital twins deployed in across all the property portfolio.
Thanks, Kishore. That's great. I'm just very conscious of time. We've only got 3 minutes left. So Andy, I don't know if there's anything you want to be able to pick up on BIM, and there's also quite a lot on data collection, on ethics and security, and sort of because the data is so cheap to collect, with not organisations perhaps knowing what they're going to be doing with it.
Yeah, there's a couple of key points in there. There was one I've just answered to Darren that was about connectivity on a rollout. So a lot of the gateways that we use have got SIM cards in, so if you don't have hardwired connectivity, there are options to be able to use the mobile network, because a lot of the data is quite lightweight anyway. Some of the things that we do, certainly when you're doing things like a temperature, you don't want to be taking that every 30 seconds because it doesn't change over a 30-second period. So temperature is something you can almost do once every 10, 15, 20 minutes, for example. Doesn't necessarily generate a lot of data, so it works quite well over a SIM card. It depends on what the sensor is actually doing. When it comes down to just a couple of things, is BIM actually a blind alley potentially. Some of the things, it's for us, some of the systems that we find, some of the on-prem systems, if you will, are quite old and don't really have ways in which we can actually connect to them anyway. If they do, it's via a physical cable. If we're talking about the on-prem system, if you will, and the management system. So sometimes it's not really possible to get some of that info and some of the data to go on to. Are we collecting too much data? Again, it comes back to, I think, what questions are you trying to ask? I think there's a few organisations I've worked with in the government space that have built out concepts that I would say have not really gone anywhere because the questions come after, and that's exactly that reason. We've got the data, it wasn't particularly expensive to get the data, but what are we now using it for? And the project sometimes loses some traction. Like back to anything, there's got to be a use case with a set of questions that we want to answer, otherwise it almost becomes a bit of a vanity project. But I think now what you're seeing is a significant amount of use cases that work at the right price point, that allows us now to build out scalable solutions that give us rich data. I believe there's data in there. There's some wonderful data that we've had that we didn't think there was any data for some local and regional governments in bin collection data, but that tells us so much about some other areas in the local and regional government sector that we can use that data to cross-correlate with, and it provides massive amounts of value. So at the first glance, it doesn't look like, sometimes what value is in this data. It's when we start to, get the innovation around what kind of questions that we want to ask. Do we actually find that data is quite valuable? But, going back and starting small and growing out is always the best way to do it and get some organisational buy-in. Because there's a lot of data out there that you can get that maybe you could spend weeks trying to mine and not really getting anywhere. So absolutely, all valid points. I think with Bruntwood, it was, if we go back to that particular example, appreciate it's not social housing, it's more commercial space, but fundamentally, the sensors and the standards and what we build is fairly similar. There was a big drive there to modernise operational processes and rip so much cost out of how that organisation runs in general, and then at the same time maximise the cost per square foot in city centres because of how expensive it is, and create that into a business model. So it's actually a no-brainer for that organisation. You know, the business case stacks up really well. So on that note,
thank you. I'm just conscious of time.
Yeah, bang on 12.
We've still got lots of questions, so we
can take them offline, and I can get the person. You know, we can answer them individually, and I can email them back directly if that's something that we want to do.
We'll make sure that we come back and answer the questions, and we'll send out to everybody a copy of the recording and the slides too. So thank you very much for joining us for this webinar. I hope you found it really interesting. Thank you.
Thanks, Jenny.